Exercise 2.47. In example 2.5, suppose that the attachment point of cable A is moved so that the angle between the cable and the wall increases from 40 degrees to 55 degrees. Draw a sketch showing the forces exerted on the hook by the two cables. If you want the total force FA plus FB to have a magnitude of 200 pounds and be in the direction perpendicular to the wall, what are the necessary magnitudes of FA and FB? So, as always, first I'm going to solve the exercise, second explain what was needed for me to solve it. Of course, I'm going to explain what I'm doing while I'm doing it. The first step is to change this value because the exercise is telling us to change it to 55 degrees. The second step is to write down or show through a draw, the forces exerted on the hook. So that is what we will do at this point. First, this is going to be called my point zero, right? The origin of my analysis. Right here we have the x-axis, and perpendicular to it, please bear with me, we have the y-axis. Of course, this is the x-axis positive and the y-axis positive as well. Now, I'm going to show the two components of the first force, called FA. So this is FA, and I can show the first component like this. I'm going to call it, well, let's write down the full name at this moment. This angle is equal to 55 degrees, right? So right here I have a right triangle, which means that I have a 90 degrees angle, which means that this angle is equal to 90 minus 55, which is equal to 35. So 35 degrees. Hence, this force is going to be called FA multiplied by the cosine of 35. All right. Now, doing the exact same thing with the other force, I'm going to call it FA sine of 35. And that is pretty much it regarding the FA components. Now, in the case of FB, bear with me. I'm going to call this force, well, because of the same reason, this angle is equal to 70 degrees. 90 minus 20. So 90, 70, and this is equal to FB multiplied by the cosine of 70. Hence, this force is equal to FB multiplied by the sine of 70 as well. Now, we have to take into consideration the direction. Remember, for when we're working with vectors, there are only two things that we care about. The first one is the direction, the second one is the magnitude. So, the direction is given by a symbol, it could be positive or negative, and the magnitude is given by a number, a specific number. So, this component is positive because it's pointing toward the same direction of x positive, right? which applies for this one and this one. Now, this one and this one. Now, because of the same reason, this force is positive, is pointing towards the same direction for y positive. Therefore, this one have to be negative, right? Now, we will, well, actually, we already did the first requirement of the exercise. Draw a sketch showing the forces exerted on the hook by two cables. This is a sketch showing all the forces that are being applied to the hook. And now we will solve the second part of the exercise. We will look for the values of FA and FB meeting one requirement, which we will see during the process. Now, the vector FA using its components is equal to FA cosine of 35 plus FA sine of 35. Of course, this FA is the magnitude of the vector. Now, the vector FB is equal to FB cosine of 70 minus FB sine of 70. Now, we have to make sure that we place the direction. And this direction is being set by these symbols. This is along the I direction, and this is along the J direction. As you could imagine, the I direction corresponds to the x-axis, and the y and the J direction, it corresponds to the y-axis. Okay, this is the nomenclature that I always use. Of course, you will notice that some authors in different books uses another one, maybe uses an E or something like that, but it is pretty much the same stuff. Now, we will do a summatory of forces, but we have to take into consideration that statement that I mentioned before. This statement is that the summatory between the forces has to have a magnitude of 200 pounds and be in the direction perpendicular to the wall. Which is the direction perpendicular to the wall? The same x-axis in my sketch, right? So, hence, I can say that the summatory of forces along the x-axis, in this way I'm going to take the positive numbers. For those of you who may be thinking, what is this? Is this the way of me saying that I'm going to take all the positive numbers towards this direction? Which means that it's the way of me saying that all the forces towards the direction that I say, that I indicate right here, are positive, are going to be positive, and the other forces, hence the forces that points towards the opposite directions, are negative. All right, in my case. Now, I'm just going to use the information within the first column. So FA, the magnitude, cosine of 35, plus FB, the magnitude, cosine of 70, is not equal to 0. All right, it has to be equal to 200 pounds for us to meet the requirement. All right, so this is equal to 200. Now, the summatory of forces along the y-axis, it has to be equal to 0, because if we want to meet this requirement to have a magnitude of 200 pounds and be in the direction of perpendicular to the wall, this direction, perpendicular to the wall, 90 degrees angle, and then I don't really care about the forces along the j-axis, which correspond to the y-axis. Hence, the summatory of forces is equal to 0. Now, once again, I'm going to write down this statement, and basically I'm going to write down the information within the second column. Sine of 35 minus FB sine of 70. This is equal to 0. Now, we have one equation, two equations, one unknown, two unknowns, one unknown, two unknowns. So we have the exact same amount of unknowns and equations. So basically the problem is solved. We will use the calculator for us to solve this exercise. So we are going to click on Mode Setup, 5 equation. This is a grade 2 equation with 2 unknowns. So A plus B equals C. And we will write down the information that is next to the unknowns, and at the end we will write down what is after the equal. So in the case of the first row, we will write down cosine of 35, cosine of 70, and 200. Make sure that this and this corresponds. All right, for example, if the order changes like this, this is still correct. All right, it is still correct, but when I'm going to put it within the calculator, I have to make sure that this, which corresponds to the FA unknown, have to be placed within the first column. All right, so in this case, cosine of 35 be cosine of 70, which is this, and this is equal to 200. So A, B, and C. Now, A, I've placed in the first row the information of FA first. So I have to do the same thing regarding the second equation. In this case, sine of 35 is next to FA. So I'm going to place that right there. FB minus sine of 70, and this is equal to 0. So A, B, and C equal X, which stands for FA, the first unknown that I've placed, FA is equal to 194.5682. I always use 4 significant digits after the point. And FB equals 118.7620. And that's it, guys. This is how you can solve this exercise.